All right, so a little bit more with magnitude and direction. I now have components of my vector are 3, -4. So that means I go from the origin, right 3, down 4. So there's my vector. In order to get the magnitude of this vector, I'm going to do the square root of the x component squared plus the y component. And so we have 9 and 16 make 25. So I have a magnitude of 5. The direction needs to be the angle from the positive x-axis all the way around. But in order to get to that, I need to use this little reference triangle here. I'm going to find the angle in here with the x-axis. So I know this is a -4 and this is 3. So the angle is going to be inverse tangent of the y value over the x. Now I'm going to go to my calculator. So second tangent, whoops, -4 over 3, and I get -53.13. All right, so again, that's just the angle. It just indicates to me that that's a clockwise direction from the x-axis. So the reference angle would be the opening, which is 53.13 degrees. But in order to get the green, right, I need from the positive x-axis all the way around. So I'm going to do 360 minus my reference angle, and that's going to give me my direction. And so I get 306.87. All right. Drawing the vector often will help you make sure that your answer is in the right quadrant and all those things. But also, I didn't really say this before, but when you give a direction angle, we always have to do a positive angle from 0. All right, next one. Magnitude and direction, a vector with initial point 2, 3. So over 2, up 3. And then -1, 4. All right, so that's my terminal. So my vector is going that direction. All right, so if I imagine here, my x component is going to be left 3, so -3, then I go up 1, so the component form would be -3, 1. So the magnitude is going to be the square root of -3 squared plus 1 squared, which is square root of 10. So that's the magnitude. If you are asked to give an approximate, then you would take the square root of 10 and get 3.16. So that's an approximate. And then here I'm going to find the angle or the direction. So what I have to imagine is I have to imagine like this is sort of my x-axis. Here's my standard position. So I need this angle all the way from the positive x-axis around. So I'm going to say inverse tangent. My angle is going to be inverse tangent of the y over the x, right? Opposite over adjacent. And so I'm going to go to my calculator. I could have put the negative with the 3. I'll make this 1 over -3. It doesn't matter where we put the negative. So I get -18.43, which tells me that I have a reference angle of 18.43. And in order to get my actual angle or my direction, I'm going to do 180 minus the reference angle, because 18.43 is this angle in here in the reference triangle. $161.57. All right, so that's my direction, and square root of 10 or 3.16 is the magnitude. Once you got the components, you could have regraphed this down at the origin if that helps you, Negative 3, 1 would have been this angle here. And if that helps you understand the angle a little bit better, that's fine. You also can do what I did and draw in the little axis at the initial point, and then that will help you get a visual for your direction. All right. Determine the horizontal and vertical components for a vector with magnitude 8,000 and direction angle of 155.1. So 155.1 is going to be in quadrant 2, right? So it's this angle here would be 155.1, and the magnitude is 8,000. So that means that this y component and the x squared plus the y squared square root gives me 8,000. In order to work backwards though, we're going to actually use sine and cosine. So if the whole angle is 155.1, I can find this like reference angle. So 180 and 1 minus 155.1 is going to give me the little reference angle, which is 24.9. So that's the angle in here. And if I want to solve for y is opposite over hypotenuse, which is sine. So I would do sine of 24.9 is opposite over hypotenuse. And so then ultimately I'd multiply both sides by 8,000. And so I'm going to go to my calculator and put that in. 8,000 times sine of 24.9, and I get 3368.29. And here, by using the 24.9, I have to then think about the y. The y is in the positive direction, so I need to choose a positive number. There's actually a shortcut here, though. Whenever we're trying to find the y component, we're going to take the magnitude of the vector times sine of the direction angle, and that's going to always give us the y value. And if I would have used this 155.1, then I won't ever have to worry about figuring out if my sine is correct. So let's try that for the x portion. To find the x portion, instead of doing cosine of 24.9, I'm going to do cosine of 155.1, and that's going to be adjacent, which is x over hypotenuse. Multiply both sides by 8,000. And by doing this, I'm going to automatically get a negative number, which I should get because that's on the negative x-axis. And it's negative 7,256.35. So my x component is that, my y component is this, and so it's okay if you just add as x and y, or we could go ahead and write this in component form. Oops, 56.35, 3368.29. All right, so again, you could go through the whole process and find the reference angle, but if you do it this way that I have in blue over here, if we do it this way, then when you get your answer, you have to pay attention to where you are in the coordinate plane to figure out if you have a positive or negative value. The shortcut is to use the actual angle given to you, the direction angle, with your sine or cosine piece, and then that's going to give you the right value with the right sign. So in general, when I want the x component, I'm going to take the magnitude of the vector times cosine of the angle. If I want the y component, it's going to be the magnitude of the vector times sine of the angle. And if you ever forget that, you can figure it back out because it's just a right triangle. All right, stay tuned for some